Let's take another look at probability trees and maybe see it in a different light. I either jog to work or I take the bus. On Monday, the probability that I jog is 0.6. Complete the probability tree below. Well, I either jog or I take the bus. So it won't surprise you that these two are going to add up to 1. And so the probability of taking the bus is 0.4. Right, simple stuff. But let's imagine there are 100 Monday mornings. What a very unpleasant thought that is. However, I nearly said jog on. We'll keep going. Right, we've started off with 100 Monday mornings. 0.6 of them are going to be jogging mornings. So it won't surprise you to know that 60 of those I'm going to jog in. And I'll take the bus on 40 of those days. Now, we start off with 100 and we finish with 100. We haven't lost any because the probability of doing both of these, they're the only probabilities there are. They add up to 1. We've still got 100 Monday mornings. Let's add Tuesday. Now, if I have jogged in on a Monday, I'm probably going to be feeling a little bit tired and I've done my job maybe for the week. So not likely to jog in on Tuesday, 0.3, and a mystery probability I take the bus. However, if I have taken the bus, I will be dirt keen to go jogging on Tuesday. Probability is 0.8, and then a mystery probability I take the bus. It won't surprise you to know that these two add up to 1. I'm either jogging or I'm taking the bus, so that's going to be 0.7. And again, I'm either jogging or taking the bus. That is 0.2. Right, so coming along from here, 100 mornings, 60 of them I jog, and 0.3 of those I jog again. So that is 18. Of these 60, 0.7 of them I take the bus. That's 42. And of these 40, 0.8 of them I jog, 32, and lazy boy, second day running, I'm taking the bus. 0.2 or a fifth of those I am taking the bus. That's 8. Now, we've got 100. We've got 100 Mondays, and after Tuesday, there's still 100. Because we haven't lost any. You have gone along, or I have gone along one of these paths. Okay, let's add a little bit more mathematique to this. There's 18 here. Of the 100 starters, we went to 60, we took 0.3 of those, we went to 18. So what's the probability that one of these mornings becomes one of these mornings? Well, it's 18 divided by 100, and that equals 0.18. 0.42 of these mornings goes jogging, takes the bus. So it's 0.42 is the probability of travelling along there. 0.32, 32 of the mornings I end up busing and then jogging, and a mere 0.08 bus and bus. Now, obviously, these add up to 1 because the sum of all the possible probabilities is 1. But interestingly, what have we done here? We've taken 0.6 and then we've taken 0.3 of 0.6. which you know is the same as multiplying 0.6 times 0.3, and that equals 0.18. Here, we've taken 0.6 and then 0.7 of that, which is the same as multiplying it. 0.6 times 0.7, 0.42. Travelling on this one, 0.4, and I've taken 0.8 of that, 0.4 times 0.8, and likewise this one, very small chance here, 0.4 times 0.2 is 0.08. They still add to 1, of course. So let's just look at the top end just so we can focus on these. The probability that I jog on Monday and then jog on Tuesday is equal to 0.6 times 0.3, and that's equal to 0.18. The probability that I jog on Monday and then bus on Tuesday is equal to 0.6 times 0.7. Is 0.42. We don't actually need these hundreds of blue dots anymore. So let's take them away. And this is probably the classical probability tree that you know and love. Monday, probability of a jog, 0.6 probability of a bus, 0.4. And likewise on Tuesday, these probabilities depend on what I did on Monday. And if I want to know the probability of travelling along any of these lines, as it were, 0.6 times 0.3 is 0.18, I can just multiply that out, and the chance of me getting here, the probability of a jog and a jog, is 0.18. Probability of a jog and a bus is 0.42. Travelling along there is 0.4 times 0.8. Probability of getting here is 0.32. And finally, the small one, 0.08. And of course, they all add up to 1. So when you see one of these trees at any fork in the road, the probabilities will add to 1. If you want to travel along one of these lines, you multiply the probabilities, because these are two separate events. Monday jog or bus, Tuesday jog or bus. We multiply the odds together. Let's have a look at that question. This is from the exam. The probability that Kathy cycles to work is 0.6, so it's 0.4, doesn't cycle. And then we know that it's 0.3 that she cycles and then cycles on Tuesday. And it's 0.4 and then 0.1 that she doesn't cycle if she hasn't cycled on the Monday. So what's here? Well, it's a fork in the road. So these two are going to add to 1. She either cycles or she doesn't cycle, so that's going to be 0.7. Again, cycles or doesn't cycle. These two are going to add to 1, so that's 0.9. The real marks, 2 and 2, calculate the probability that Kathy cycles to work on both Monday and Tuesday. Well, Monday probability is 0.6, and if she's cycled, the Tuesday probability is 0.3. I multiply these two together and I get 0.18 for 2 marks. Surprisingly easy now is the second question. Calculate the probability that Kathy does not cycle on either day. So we have 0.4 here, does not cycle. And having done that, it's 0.1, does not cycle. So 0.4 times 0.1, 0.4 times 1 equals 0.04. Nice little question. Easily answered once you know what you're doing. So we've taken something that's a bit tricky, and I hope we've made it easy. Please subscribe. We've got loads of videos and we're getting more and more and more. If you're taking the exam in November, best of luck.